本日はご対応の中、ロボット
Thank you very much for participating RRI International Symposium 2020 today. I am Nakashima from RRI. I will be moderating today's session. Before going into the session, there is one request that I would like to make. Today, due to time constraint, we won't be able to have Q&A session. However, should you have any questions related to the seminar or the sessions, please send your question to this RRI address that you are seeing on this screen. We will be getting back to you in a later date. So today we are going to have the third day of the symposium. This is the Japan-Germany Experts Forum. This is hosted by the Ministry of Economy, Trade and Industry of Japan, as well as the BMWi, the Federal Ministry for Economic Affairs, Energy of Germany. So in 2017, we had this cooperation agreement between Japan and Germany. And today, we will be giving you the updates about what kind of activities that we are doing between RRI and Industry 4.0 of Germany. The Hannover Messe in spring and the International Symposium in autumn are considered to be the checkpoints. And in this respect, we are having this International Symposium today. It is going to be a very long day today, but I hope that you will be staying with us as time allows. So now, without going into the session itself, I would like to invite Mr. Tsuyoshi Yano, the Director of the Manufacturing Industries Policy Office from the Ministry of Economy, Trade and Industry, to give us the opening remark. Thank you very much for your kind introduction. My name is Yano from METI. Let me give you the brief opening remark. So thank you very much for your participation to the Robot Revolution in Industrial IoT International Symposium organized by Ministry of Economy, Trade and Industry and the BMWi, Federal Ministry for Economic Affairs, Energy and RRI. Taking this opportunity, I would like to extend my appreciation for today's presenters as well. Japan and Germany's IoT and Industries 4.0 related initiatives started back in March 2016 between BMWi and METI, announced a joint statement on Japan-Germany IoT Industry 4.0 cooperation, and welcomed by Prime Minister Abe and Chancellor Merkel in May same year. Later, in March 2017, at Hanover Declaration was issued at CBIT, and international standardization and concrete discussions have started to take place, and experts meeting put together joint documents. It is nice to see specific outcomes are made. Also in a CBIT, Japan laid out a new vision which shows future state of Japanese industries. Japan is going to aim for the industrial society where new added value would be generated by connecting industries, companies, people, data, and machines. This is what we call connected industries. From 2018, while B2C platformers represented by GAFA are growing its presence in the world economy, discussions have started to take place on deeper themes. To name a few, Professor Dr. Kekerman's proposal on a building B2B platform in manufacturing area openly to take part in the platform economy, as well as what will be the desirable relationship between human and machines against the backdrop of a rapid evolution of technology and digitalization. Well, a third dialogue is taking place between two countries, and though the COVID-19 is still spreading, this international symposium is taking place. Participants can listen to the latest research and initiatives on the topics of data flow, business model transformation, industry security, standardization, collaboration from experts in the field. And I myself is very much looking forward to it. All industries are undergoing dynamic transformation in the world. what was advocated in Industry 4.0 and connected industries, like a value creation through collaboration and co-creation between human and machine, technology and system, is considered to be no longer new. The front runners in the world are already starting to consider beyond that. That is how those vast data generated from these activities can be utilized. Using AI in cyberspace and leverage them in business activities and economic activities in physical space. What is analyzed from those data to be shared with society as a whole to solve social issues like aging society. To do this, how organic data should be linked and a built platform is the phase frontrunners are discussing. In order to take a part in this discussion, I'm confident that what we are expected to do is to lead the international discussion in a field of data flow, business model transformation, industry security, standardization, since Japan and Germany are advanced in manufacturing and we can collaborate in research. And I hope today's session is going to be meaningful one for you. And with this, I would like to conclude my opening remark.
Thank you very much, Mr. Yano. Next, we would like to ask Mr. Markus Hess, Deputy Director General of the Federal Ministry for Economic Affairs and Energy, for a few words. Mr. Hess, please, the floor is yours.
Thank you very much. Konbanwa to Tokyo. Good evening, everybody. Please.
Sir, your mic is muted.
Konbanwa to Tokyo. Minasan, ladies and gentlemen. A warm welcome to the Germany-Japan Expert Forum on Industry 4.0, the connected industries from my side too. Our cooperation has grown over the last 4.5 years. It is quite strong and quite unique. We are very well connected. Even the coronavirus cannot stop us. Experts are still working very intensely together. And as we all see, we are together in this cyber room. More importantly, the coronavirus and its impact on the global economy shows that there is a great need for digital solutions. In fact, it is the companies that are well advanced in the digitalization process which are best equipped to manage the current challenges. That's why we are currently seeing an even stronger push for digitalization in our economy, industry, and every field of our life. To underline what Mr. Yano has just mentioned, I would like to switch to the next slide. In 2016, METI and our ministry started the cooperation. They signed a joint declaration on cooperation regarding Industry 4.0 and connected industries. Over the years, those cooperations were enlarged and deepened. In 2017, both ministries signed the Hannover Declaration. In 2018, in terms of IT security, the cooperation started with a common position paper. Mr. Yamda will focus on this later on. It's quite interesting. And in the field of standardization, a common strategy paper was published in 2017. A use case scenario and value-based services was published in 2018, and a use case scenario on the asset administration shell in 2019. This year, RRI and the Industrial Data Space Association signed an MOU. Professor Otto will present new developments there, and he will touch upon the new Gaia-X project. As you can clearly see, there is progress in existing fields of cooperation, and at the same time, new issues of common interest are taken up. Since 2017, mutual SME visits have taken place. In the field of R&D, we agreed a cooperation of supporting schemes in order to fund joint research projects. In September 2018, RRI held a seminar on work, education and training. And this year in September, Professor Kagaman, Dr. Nonaka from Hitachi in cooperation with RRI and Platform Industry 4.0 published a paper on revitalizing human-machine interaction for the advancement of society. So further experts will present some results on these. Next slide, please. Here you can see some examples of this combined work. It covers the stretch between a joint statement of manufacturing policy or the role of trustworthiness, seamless dynamic plant engineering, or common strategies, which is extremely vital for our cooperation and underlines that we come to terms and good results. Next slide, please. For a second, let me stress one of these subjects that will, to our understanding, shape industry in the coming years. We call it the Gaia X community. Professor Otto will go into more detail later on, but for now, I would like to invite you to participate in the project Gaia X. There are multiple ways how to participate. Some Japanese companies are already engaged. One option is to participate on the user side by setting up a Gaia X hub. That is the left-hand side, the blue box, that can incorporate all the work that has been done in the field of connected industries. The beauty of Gaia X is it won't reinvent the wheel, but build on existing solutions, even international ones. And the membership in newly found Gaia X Association is possible as well. That is the green box to the right. And there are possibilities to set up common projects and use cases. Of course, you can realize all options simultaneously, launch a Japanese Gaia X Hub, become a member of Gaia X Association, and set up a use case. I'm looking very much forward to that, and I hope we will find a good next chapter in our cooperation. Now the floor is open to the experts. Next slide. Thank you very much for your attention and have a very good day. Last slide, please. Thank you very much. Thank you very much for your attention. Thank you.
はい、ヘッツさんもありがとうございます。そ
Mr.
れでは
Hess, thank you very much. And now we would like to move over to the expert session. And the first topic is the principles of a trusted data infrastructure, German, European, and Japanese perspectives.
RRI にてグローバルデータ流通管理
So the-
基盤検討ワーキングサブワーキンググループの主査を務めております。
Now the speaker here is from NTT Communications, Mr. Sakaino, and from Germany, the International Data Space Association's Vice Chairman, Mr. Otto, is going to be other speakers. Good afternoon. The RRI Subworking Group 8. I am heading this team. My name is Akira Sakaino. And in this session, theme is how trusted data infrastructure should be from Germany, Europe, and Japan. So firstly, I'm going to talk about data management trend and global data management platform requirement, which we have discussed in RRI. And Professor Dr. Otto will introduce what IDS Gaia X is doing, and then I will talk about future efforts. As you may know, for the sake of innovation, productivity improvement, and technology succession, Japan is working towards connected industries where manufacturers, users, workers, and IT companies are expected to connect to each other and use data. However, in reality, I don't think they are connected and data is not used enough. Why? This is a list of barriers to data sharing, which I put together. Many old analog machines, different interfaces, no good place to store data, no secure system to share data with other companies, no clear rules to share data with foreign companies, complex system operations and contract management, security is difficult, many data protections regulations, risk of data misuse. Therefore, there is a need for a new system to share data easily, globally, and securely. Looking at the global trend, governments and companies are well aware of the importance of data and came up with innovation strategy sharing data. Meanwhile, there is a risk of data lock-in by IT companies and a government's abuse of a data restriction. Thus, there is a move for countries to protect their data sovereignty. This is the very reason why I think there is a necessity of establishing fair common rules and platforms for international data sharing. Do you know what data sovereignty is? Put it simply, it is to enable data provider to control who can use data for what, when, where, and how, based on laws and contracts, so that a person with no contract and hackers cannot access them. Against this backdrop, October last year, Global Data Management Platform Sub-Working Group was launched in RRI, trying to define requirements to create platform to share and manage industrial data of manufacturing companies securely, fairly, and globally. These are the member companies. We want to carry out a connection test with IDS Gaia X and develop the platform next year. And in this sub-working group, we followed these 5 steps to identify requirements for platform. Let me briefly explain each steps. In the first step, we ask sub-working group members what are the barriers for them to share data. In the second step, RRI narrowed them down onto the issues relevant to system requirements. In step 3, listing up concerns of data sharing when one shares industrial data with foreign companies based on specific use case. The use case we used was a future business model called Factory as a Service, FaaS. When manufacturers detect machine parts exported to foreign countries are wearing using IoT and AI, send parts design data to local partner factories via FaaS provider and let them manufacture replacement parts on demand. In this use case, data provider, intermediary, and a user brought concerns and risks in relation to human, product, data, money, and data they manage in each data processing stages, and they summarized them into 134 items. In step 4, categorize them into these 11. In order to mitigate concerns and risks, we came up with the necessary functions and roles of Global Data Management Platform. And in the next step, functions are detailed out and developed into system requirements. To show you one example, let me show you the blue highlighted portion, setting data usage rules for each partner's reliability level. And this is a step 5, an example of defining system requirement to realize the solution. Detail out the basic requirements related to rules, technology, and organization, and came up with system requirements on the right-hand side of this slide. Following these steps, a global data management platform requirements are summarized into 16, and today I want to highlight 5 of them. And this is it. The first requirement is a data processing traceability. Assign unique ID to identify its origin and nationality to data processor equals participant, hardware, software, and data to trace input-output of data. And this is needed to check the validity of its data use. The second is automatic management of data and governance. Convert contracts and laws into digital decision logic so that software can interpret and be able to automatically detect rule violation and data misuse. The third is automatic data disclosure control by credit score. Scores participants' credibility with a common scale using their data usage history. Depending on counterparties of credibility, system automatically controls if data can be disclosed and determines the scope of data disclosure. The fourth is automatic data disclosure control by location information. Using GPS and telecommunication access line of participants, track down where they are, and based on technology export control law, determine should data be disclosed or not. The fifth requirement is a data auto-delete disable function. After authorized participants use data, there is a need for function to automatically delete or disable a data when contract period expires. In order to build data management platform suffices aforementioned requirements, we are expecting IDSS, ODS, and Gaia X to be very useful. So now I would like to invite Professor Otto from IDSA to talk about IDS.
Yes, hello from my side. My name is Boris Otto. Thank you very much for the kind introduction and also for the invitation to share a couple of thoughts about how to build data spaces and the role of Gaia X and IDS in that context. I feel very honored for this opportunity to share, as I said, a couple of results and also making the invitation to collaborate even further in the future, as also outlined by Mr. Hess, for example, earlier on. I structured my presentation in mainly 3 parts. As mentioned earlier, I would like to speak a little bit about how to build data spaces, because as you know, data spaces are one of the key instruments or means which allow us to engage into data sharing and in that sense also embark and leverage the potentials that we see in innovative smart service scenarios. In a second step, I would like to introduce to you once more the 2 initiatives that merged or are closely aligned, which are Gaia X and IDS. And also tell a little bit about potential next steps when I come to the outlook. When we speak about data spaces, as mentioned, we realize and can observe that this is a very hot topic these days, not only in Germany and in Europe, but across the world. And to underline this point, I took here with me the cover pages of the data strategies that were recently published or are being published every week. On the right-hand side, you can see the principles of the German strategy for data, which, as I said, will be released in a version 1.0 very soon. And on the left-hand side, you can see the cover page of the European equivalent, so to say, so the European strategy on data. In particular, the latter one is calling for the creation of 10 individual data spaces for certain domains, for example, industrial, but also mobility and healthcare. But the question, of course, is now on the table, what exactly a data space is and how to build one. We all are very sure and positive in the sense that data spaces will spur innovation and therefore also competitive advantage and societal prosperity. But we need to altogether respond to the question, well, how can we actually build data spaces in order to leverage this innovation potential? Therefore, I have looked up once more the key design principles of data spaces in general, but then also what, let's say, the international data spaces added on that. And if you look, let's say, on the first part, you can see that general design principles of data spaces consists of, let's say, no physical data integration, but rather leave the data where it is. So it basically promotes the idea of federated data architectures. On the other hand, data spaces do not require a common schema. So it does not want to force all the data into one database schema, but rather wants to create or achieve interoperability on a semantic level. It also foresees data networking and data coexistence, which means due to the fact that data remains in a decentralized fashion, that there are also redundancies of data, which is okay because multiple data items may be used or owned or possessed by different players in the field. And of course, data spaces can be nested so that in the end, a data space can basically consist of other data spaces as well. And that also is important to understand because it tells us a little bit that data space creation is not a typical one-off IT project, but the evolution of data spaces is pretty much ongoing over a long period of time because data spaces are growing, keep on growing over years, right? So saying that, so that fits nicely to what was also heard by Mr. Sakaino. We added from the international data spaces 2 further design principles, which are data sovereignty and also traceability, which has also been nicely addressed in this presentation by Mr. Sakaino when he also called for, let's say, tracking of data transactions. And of course, we added trust in participants because it's a federated way of data integration, an ecosystem-based one. And in that sense, it's very important that participants in the data space, members in the data space, can trust each other. Saying that, I brought here a little bit a view graph of how this can materialize, because as I said, the question on the table is, well, now when we have understood what a data space is, how can we together build one? And I took here the example of the mobility domain, which is currently driven forward in Germany as well. And it's always useful in our understanding to distinguish between 3 architectural layers. On the top, so the green layer basically depicts what we want to achieve, the mobility ecosystem, which is based on the, let's say, on the use and development of smart mobility services end to end, which allow us intermodal mobility. So I go from A to Z using different means of transportation, and everything is orchestrated by an integrated service. And of course, it is clear that in order to achieve this ecosystem, underneath in the second layer, we need to have a common data space where all the data objects and data items are linked to each other and brought together and can be combined. And we refer to that as the shared digital twin in a certain domain. And of course, that requires software components underneath, which brings us to the lower layer, which, for example, the IDS infrastructure can be used, which basically delivers or specifies, to be precise, all the different software components that are required in order to create such a shared digital twin. These comprise, for example, the IDS connector, but also other components like clearinghouses and broker services. So, and then when we have understood what kind of architecture we need to build up, then the question usually arises, okay, who's responsible for what? And that brings me to the next chart that I'd like to outline, which can be seen as an onion model, to use this phrase, for data space design cooperation. And when we look into the onion core, so the inner circle of the onion model, we can see that IDS as well as Gaia-X, which I will come to later on, are aiming at providing the standards, the specifications that are needed to build up this decentralized federated data infrastructure, which rests underneath the data spaces and the data ecosystems. Remember that the colors are the same as on the previous chart because they refer to the various or the 3 different layers. The second onion ring, which is labeled data space commonalities, requires us to work together in certain domains, in particular also in the Industry 4.0 domain. We need to come up with domain-specific vocabularies in order to create an unambiguous understanding of the things. So we need to understand the same things in the same way, which is why, let's say, the proliferation of the asset administration shell is of utmost importance, because the asset administration shell addresses in particular this point. And in the outer ring of the onion model, then we have the individual business models, the use cases, which should be driven forward by individual consortia and players. So in the inner circle, as said, we can use standards. In the middle circle, we need to work together. And the green onion ring basically is where individual business models, new business models emerge. We also need to understand that these data ecosystems based on data spaces cannot be created from one day to the other, but they rather follow an evolutionary path. What we see in many cases is that on a bilateral basis, use cases are started. So companies start to exchange data using data sovereignty standards and architectures. And then this collaboration grows towards often closed community data sharing. But in the end, of course, we want to reach open ecosystems where in a dynamic way, members can participate and engage and share data among themselves and trust in the identities of the other participants. So this is about, let's say, what data spaces are and what steps are to be taken in order to build data spaces, and in that sense also live up with the expectations outlined in the various data spaces that we see. So what is the contribution of Gaia X and IDS in the next sense? Gaia X is addressing cloud and data sovereignty, and that means that we address data sovereignty when the data is shared. And I was very glad to see that also in the presentation by Mr. Sakaino, who basically outlined very, very good examples for requirements about data sovereignty and data sharing. But of course, data sovereignty also means to respond to the question, can I control as a data provider where the data has its home? So basically where the data is stored and where the software components, on which platforms the software components run that I use in order to build up data spaces. Gaia X, as you know, has started around about a year ago and has grown significant attention from all over the world. It has now basically attracted more than 120 organizations from all over the world. And the objective is to provide a couple of federated services, which you can see here highlighted in green, which make sure that the data ecosystem depicted in blue and the infrastructure system depicted in red are linked and brought together. And together, data sovereignty, both for data shared, but also for data stored, is achieved. And these federation services relate to the to federated identities shown on the upper left-hand side, on the sovereignty in data services. So coming back to Mr. Sakaino's examples, very, very good examples for data sovereignty. It goes into the direction of the lower left-hand side, a federated catalog. So every service, every cloud service that meets the requirement of Gaia X must be made findable and searchable in a federated data catalog. And of course, we need to establish a compliance framework in order to make sure that only those services get, let's say, certification through Gaia X, which comply with the Gaia X certification criteria. So Gaia X is a non-for-profit association which aims at setting a standard for cloud and data sovereignty. It will develop an architecture of standards, as Mr. Hess said, which makes use of existing standards in order to be quick and fast, which basically can be used by everybody who wants to stick and adhere to policies for data and cloud sovereignty. As I said, the Gaia X Association will make use of existing initiatives and standards, and one of those is the IDS initiative that you all know. I used here the view graph of the first milestone for standardizing the IDS architecture, which is the DIN spec 27070. As you know, this is in the family of the 27000 ISO standard, which deals with information risk management in general. That is no coincidence, but we positioned the standardization initiatives from the IDS perspective in that domain. Right now, as I said, the DIN spec has been published in February, I believe, this year. And the process has already started to make it an ISO standard with the same number. And I think that is very important. And the DIN spec, the standard so far, describes and specifies the IDS architecture, identifies and specifies the different components and their interaction among each other. So how does these two things come together? You can see here a first version of an integrated picture of an integrated architecture view graph that brings together, on the one hand side, the ambition of Gaia X to address both data and cloud sovereignty, but also shows a way how the IDS components can be integrated into the overall Gaia X picture. This proposal has not been published yet, and I want to stress the point that was also made by Mr. Hess. The process to bring things together has been started with the formal incorporation of the Gaia X association, which I will outline later on. And I would like to invite everybody to take part in this process and contribute to this, because this is a process from us as a community, for us as a community, which is a big asset in my point of view. Also, I'd like to give you a little bit in status overview. With regard to the IDS association, I mentioned earlier that the reference architecture model is now being in the process of being proposed or being worked out, elaborated as an ISO standard. As well as the certification criteria are fixed. It basically works as a trust anchor, because the IDS association will be responsible for issuing digital certificates and tokens, which basically can be used by IDS software components, IDS compliant software components, to basically live up to this trust. Important is that we started an open source software repository, the IDSG, in order to make sure that the community can also contribute not only to the specification of the architecture, but also to its implementation. And we have lots of, let's say, dissemination and transfer activities, which have already been taken up by our collaboration. In terms of Gaia X will be, as mentioned, the umbrella organization for many, many individual initiatives, for example, IDSA. We have on September 15th, achieved the first milestone of the formal incorporation of the Gaia X association by passing the notarial deed in Belgium. The specificities of the Belgium legal form require that we receive a royal decree by the Belgian king, which we expect to get until the end of the year. I'd like to point you to the Gaia X Summit, so the second red rectangle here, which will take place on the 18th and 19th of November. And I invite everybody to take part on it, because then we will basically explain how to organize the upcoming steps and to bring the different bits and pieces together. So 18th and 19th of November. So talking about Outlook, I think when we want to create data spaces, it requires a combined funding model, both from public and private sources, and in Europe from the European Commission and the different member states. In general, to bring data spaces come alive, we also need to apply the quid pro quo principle. So it needs to make sure that people who want to receive data and want to use data should also ask themselves whether they can also contribute with data. And of course, we need to think about creation and adoption models. My last slide depicts a couple of collaboration opportunities that we can extend our collaboration, which is already existing to. For example, standardization, definitely one of the key points. As I said, bringing the DIN spec to ISO. We could also think about, let's say, intensifying our work towards the World Wide Web Consortium and related working groups there. And we should develop together vocabularies because they create the unambiguous understanding that we need in order to create data spaces on an international level, in particular between Japan and Germany and Europe. We should also think of, let's say, common use cases in the Industry 4.0 domain. Examples may be the carbon footprint transparency, supply chain planning, but also financial supply chain management, among various other things. It was mentioned we have already created memorandums of understanding, but we should extend that and grow our collaboration. And with that, I would like to close. Thank you very much for your attention. Please reach out to me either through Mr. Nakashima or using my LinkedIn profile. I'm very happy to come back to your questions and looking forward to engaging with you in more detail. Thank you very much.
Mr. Sakaino and the Professor Otto, thank you very much. IDS and Gaia X initiative was taken up in yesterday and the day before that as well. Excuse me, we have some talks coming from Mr. Sakaino as well. Okay, so I would like to talk about what kind of future efforts that we are planning to do. This is what we consider to be ideal global data management platform. Confidential data and open data are separately managed. Create data platform based on each country's laws and connect factories, plants, and cities. Then each country's platform to be connected to common interface and managed securely and fairly. To realize this, I propose creating international data management platform testbed using the IDS connector, which Professor Otto explained earlier. Connecting Japan and EU data platform via common interface, conduct a POC for various use cases, and hoping to build a prototype of a global data management platform. In Japan, as NTT made a press release on September 28th, telecom companies are working towards building this testbed, and we want to collaborate with EU in this endeavor. And to this end, I am expecting IDSA's cooperation in the following two areas. One is to discuss global data management platform requirement from manufacturing perspective. I hope IDSA and RRI identify common points and differences in future vision. And two is to promote cooperation between Japan and the European manufacturers. I am expecting to see cooperation in the area of exchange opinions between companies and experts, as well as developing and operating testbeds. We want to collaborate with other organizations like a DTA in doing this initiative. And I hope everyone listening to this will participate and cooperate with us. And thank you very much for listening.
Thank you very much, Mr. Sakaino and Dr. Otto. And so once again, yesterday and the day before in our sessions, we have heard about IDS and Gaia X. Global Data Management Foundation. I believe it's not just in Europe, but on a global basis, discussions are now ongoing. Now, at RRI, as Mr. Sakaino said, IDSA, we do have an MOU with IDSA. So within these frameworks, we wish to deepen our communication and understanding so that we can have good methods for data sharing and exchange. Thank you very much for the presentation. Now let's move on to the next theme, which is business model and platform economy. Here, we will hear from Dr. Ulrich Raven from Platform Industry 4.0 AG6 and Mr. Naoki Fujino from Nomura Research Institute. This actually started in 2018 after Dr. Henning Kagerman from Akatech has called upon this initiative. So, Dr. Raven, please. Excuse me, Mr. Fujino will start. Well, yes, thank you very much for the introduction. I am Naoki Fujino from Nomura Research Institute. So, business model and platform economy. I would like to present on some of the results and outcomes that we have seen so far. Now, I'd like to explain the overview of what's being done here. Going back a bit in history, in the computer industry, in 1966, IBM developed the System 360. And for the first time, there was a clear difference and definition between software and hardware. And with the interface, different models, different organizations, different things were linked together, and that created the business ecosystem. And then that leads to the creation of personal computers. Then in recent years, in the B2C area, we see GAFA probably expanding their business and services to 200 countries. They have a zero marginal cost software and also using IT with exponentially improved performance. They are now capable of creating new business models and industrial structure. In the area of B2B, we have 3D, PLM, EDI, and XML. These international standard interfaces have been established. For example, in the apparel industry and the logistics industry, which have formed global corporate networks for years. Several tens of thousands of businesses are creating these business ecosystems, and now you have these platformers as major players. Now, but in manufacturing, there were many vertically integrated companies. So there is a product production ecosystem. However, an open platform that can scale out to promote product value as a service is still in the budding stage. It's just started. Now, against this background, Japan and Germany came together and are now trying to look at the business model and platform economy in order to look at the future growth opportunities for the manufacturing industry. I believe this is very significant for two countries. So that's the overall introduction to this presentation. And as background, context, I give 3 points. On security, communication, artificial intelligence, there are many technical perspectives being discussed in theses and other papers. And from the economic perspective, a platform economy, new intermediaries. These also have been claimed, and many ideas are coming out about this. Of course, in the B2C area, the success cases can be transferred to B2B areas. Yes, there are many of these examples. However, in general, the discussions remain on a very abstract level, and we have not reached the business level yet. So that's the understanding that we have. So the overall objective is that we want to look at the economic importance of digitalization for the manufacturing industry. We want to illustrate that, and also we want to look at some cases or use cases, scenarios that we can observe in the market and try to analyze that. As for stakeholders, well, yes, it's the manufacturing industry. But in addition to that, we need to also involve the policymakers as well as people in academia and research. So what we seek is that through these joint discussions, we hope that we can gain a common understanding of the importance of digitalization for the future of manufacturing industry. Well then, how do we want to illustrate the understanding? I'm very sorry, this is a very busy slide, but on the left-hand side, I give you some cases that have been analyzed. We have cases from Japan, from Germany, and these have been analyzed. The analysis template on the right-hand side. What are the purposes? What are the value networks, orchestration, platform, ecosystem? What are the structure of these? Especially the revenue stream. What is that revenue stream to monetize? And the business model contract. Well, where is the value being created? And the business model innovation, especially disruptive innovation. So the underlying mechanism and principles will be analyzed. And right-hand bottom here, the business model, digital platform, and the architecture and different purposes of that. And the modeled knowledge, the best practices that we've found, we want to communicate that so that it could be fed back to the manufacturing industry so that it will lead to new cases to be analyzed. So this is what we have been doing so far. So then some specific example from Japan. And also we will hear another example from Germany. So landlong. This has been awarded many awards in many areas. So you may know Komatsu is at the center in making this landlog platform. This is a little bit too busy, so I would like to use more simpler charts to explain. First of all, let's say we have a construction company at a construction site, and you have the owner at the very top. So the construction company will be responsible for the construction service, but they will be using trucks and construction machines. So the construction machines and trucks, if you are to use them, it means that you need the operators to operate them. And then from the construction management services, you may be receiving the operators. Now, you have the land log platform operator in between. To link the service provider and the construction company. And land log will help understand when and where the trucks were used or the construction machines were used and how much cost was involved. So the usage information. And the application vendor, the ERP service provider, they will cooperate, and as a cloud service, the ERP service will be provided to the construction company about the cost, etc. And of course, it's not just the cost that needs to be known. You need to understand the progress that was made in the construction work. So drone operators and 3D view service providers will provide information about the progress of the construction. And so together with the ERP information, this information will be fed to the construction company. So that's the business model of landlog. Yes, of course, the construction company doesn't have to be just one company. And the truck and construction management services provider doesn't have to be just one company. Many companies can be involved, and the user service providers. This is a multi-side platform service. That's the main point of this Landlong platform. And now I'd like to turn over to Dr. Ulrich Leven.
Thank you very much for the introduction and the opportunity to present another example. This example is Railigent. It's a platform which is offered by Siemens Mobility, and it's a platform which is in the market since several years. And I want to explain the structure of this platform and a little bit the journey, how this platform evolved. What you now see is a picture of the typical value chain in mobility or rolling stock. You have an operator of an asset, in this case a train, maybe a high-speed train or a tram. And this asset operator provides services to the end customer who uses the train. These trains have to be maintained, so there may be an additional stakeholder which maintains the asset, which is shown here in the bottom. Maybe this is a separate company because the asset operator outsources these maintenance services. And the asset itself, the high-speed train or the tram, is delivered by an asset provider, shown here in green. And these assets are very complex systems because, for instance, in a high-speed train, you have integrated many subsystems. For instance, a brake system, a door system, or the infrastructure, the infotainment infrastructure system. And they are delivered by component supplier, and the asset provider integrates these subsystems to deliver the complete asset to the asset operator. So this is the traditional value chain which you find in this industry. And for sure, the asset provider is a manufacturing company. So there is really a link to this topic of manufacturing industry, Industry 4.0. Next slide, please. And now the idea is the following, that usage data of these trains is analyzed. So to get information from the usage of the trains, to put this on some internal platform, so to store the information about the rolling stock material, and then have some algorithms to analyze the behavior and the anomalies and different things. So using intelligent software to come from the data to some insights which are valuable to be then sold to somebody who gives money for this. Maybe there is an additional infrastructure which is used as a basic, which is shown here in the bottom of the left, but this is something which is more the infrastructure part, the technical part. It does not really influence the business model. And now the critical question here, and we are discussing this from a business perspective, is how can we make money of this? And we have the typical chicken-egg problem. For sure, to have these intelligent applications, we need data from assets which we do not have, because these assets are belonging to the asset operator. On the other hand, the asset operator does not want to give data if he has no benefit. So we have to somehow overcome this obstacle to really come to a solution that we generate value for somebody, so that there are revenue flows, so that really the business model is coming into operation. And in a first step, please, next slide, please. In a first step, I want to show you how Siemens Mobility proceed to come to this step. And in this case, this is a special case of that what I was illustrating before. We see that there is an asset provider, which is also implemented by Siemens. So Siemens has here three roles. Siemens has the role of the delivery of the asset. Siemens has the role of partly maintaining this asset. And for sure, Siemens has this role of this internal platform and the analysis of the data and to generate insights. And the idea was the following, that we as Siemens do not only deliver the asset as in the past, in addition to the asset provider delivers outcome-based services. To give a concrete example, we offered this to the Spanish railway, and we also offered that all the trains will be in time, so that there will be no technical breakdown which causes a delay. This was an additional offering of Siemens, and this we can only offer because we have the know-how of the technical know-how of these trains. We have know-how how the trains are used and to schedule the maintenance measures so that we can guarantee that there will be no breakdown of some technical component. For sure, to do this, we need the data because the trains are still belonging to this rental company, the Spanish Railways, but nevertheless, there is a value proposition to the Spanish Railway because now they are on time. And to be more precise, what they realized is the following, that because of being on time, they attracted more customers. Many people, which in the past took the airplane, now changed to the train because they know these trains are on time. So there was additional revenue stream for the asset operation for the Spanish railway, and that, no back please. And this was the reason why they are willing to pay for the services, and so that there is a new business model of Siemens. So what we see is we offer additional services, we have additional revenue streams, and we have additional value network because we have this feedback loop from the usage data. But I think the most important topic here is the following, that the offering is so compelling that even Siemens could negotiate that they can use the data and the insights which they gained from this project can be used in other projects, so that we can transfer the knowledge which we get from one project to another one. And this is only possible because the operator really said, you can do this, and this has been contractually agreed. And then this is the basis for the next step. And please go to the next slide. Now Siemens has the knowledge of data and insights of the operation of trains. And now this is interesting for other parties. For instance, only to give you one example, the supplier of the brake for sure is interesting in the usage behavior of his brake. And because this is something which has been analyzed by Railigent, now there are business opportunities from Railigent for new customers, in this case, the operator of the supplier of the brake, and so that Railigent attracts new customers with new business opportunities. And I think this is the idea of the ecosystem. In order that you have additional insights, you can now use these insights to attract other people, to attract other companies, and to offer additional value propositions, and so that there is an ongoing process. But to be very clear, the basic was that you really are in the position that you have the rights to use the data and to reuse the insights from one project to another one. And this is only possible if there is a real benefit for the asset operator to give you this data. So this is the second example, which we analyzed between Japan and Germany. And please, next slide. And here you see in this table the 6 examples which we have already analyzed, and we have highlighted the landlock example, which was presented by Fujino-san, and the Railigent example, which I just explained. And I think what we see here is that these are 2 examples where we have the same purpose of the platform. Both platforms have the purpose to improve value chains of a customer. In the landlock example, there was the intention to improve the construction on site. And in the Railigent example, there was the purpose to improve the operations of the trains. And as a consequence, the structure of the platform, which is the technical basis, is very similar in the landlock example and in the Railigent example. And therefore, we created this term platform pattern. We see that there are similarities in these two examples, and please go to the next slide. And I want to briefly explain to you this IoT cloud-based platform. You see, this is a pattern where in the core you have this IoT platform operator, maybe landlock, maybe Railigent. This may be running on a computing infrastructure, which you see in the bottom. And then, first of all, there is the capability that you can connect machines to this platform, which we see on the right side. So there is a system integrator which integrates machines or systems to this platform. Then the second capability you see on the left side, you can provide apps which use data provided by the platform and which can be used to analyze this. And this can be done based on capabilities provided by the IoT platform operator, which you see on the left side. And now there is this service provider. And in the first case, we had different services provider. We had these ERP services, we had these drone services, and so on. In the example of Railigent, we had this, for instance, these outcome-based services, which were offered by a specific service provider, and they generate the benefit for the machine users. So you see the loop in the top. The machine users provides usage information, which is somehow collected on the platform. The platform offers capabilities to analyze this, and this is the basis that the service provider can provide then services to the machine users. This is the overall pattern which you find in this example. Next click, please. And now you see the corresponding revenue streams, who pays for what, and you see this has a top root, and this is the machine user. He really pays for the services, and in order to offer these services, the service provider has to use this platform, and the service provider has to connect the machines or the systems to the platform. And this can be done only by using some services offered by the platform. And this depends on the business model, whether you have to pay or whether this is for free. And for sure, if you want to use some apps, maybe you can use them because somebody, an app developer, has provided them in an app store, and then you will pay a fee to the platform operator, and then he will forward this fee to the app developer. These are the main revenue streams which you find here on the left side. So this is one generic pattern which we found in the area of IIoT platforms. And please, a slide back. And an additional click, please. Now we have seen that for these two examples, we had a common platform pattern. And it is interesting that for three other examples, the first, the second, and the fourth one, we identified another platform pattern. We called it brokerage pattern. I do not have the time to explain this in more detail, but my important message is the following, that we can distinguish different patterns. And there is necessary a business decision whether you want to implement a pattern A or a pattern B. So it's not only to talk about platforms, it's to think about what is a good platform pattern which I should choose in order to make money out of it, and so the platforms are different. And what we are trying to analyze to really understand what are these core platform patterns, and to analyze this and to come with some insights, to come with some information in order to provide this to the overall community. Next slide, please. And next. And now let me finalize our talk and give you some ideas about what we have reached so far and what will be the further steps. As already explained, we have currently analyzed 6 examples, and we are discussing whether we are analyze 2 additional examples, one from Japan and maybe one additional from Germany. And we are planning to publish this as a first result of our common cooperation, and we plan it that it may be April next year. So the main structure will be the following, that we have a general introduction to the topic, what are platforms, what is platform economy, and that we then have a description of these 6 or 8 examples. And this follows exactly the structure which was already explained by Fujino-san on the 3rd slide, I think, so that we have an overall description where we are describing the purpose of the platform. Then we have a description of the value network and the revenue streams, which we especially explained in the landlocked example and the Rayleigh example. And then finally, we have this the business model contract and the business model innovation. And we will describe this and will then have some analysis, which we will also do in this report. But in addition to finalizing this report, we will elaborate on further topics. For sure, there are mechanisms within this platform business, especially sometimes it's called network effects, sometimes it's called flywheel effect. So this dynamics of the platform business, we will analyze in more detail. Maybe that we identify additional platforms or that we find additional sub-patterns of these platforms. And there is an interesting aspect that especially in the topic of edge, we have a business perspective on this, and that we plan to collaborate here with another cooperation between Japan and Germany in the context of standardization, where we will put some efforts on this topic of edge platforms. Please to the next slide. So to summarize it, I think we are in a starting phase. The discussions on business models and platform economy has to be deepened. We have some insights, but nevertheless, we think the topic is complex and that we have to continue to go this way. Nevertheless, we think that putting together the 2 views, the view of Germany and the view of Japan, and reflecting the different perspective really generates value, which is of value for both of us, for Japan and Germany. Thank you.
Thank you very much, Dr. Löwen and Mr. Fujino. Thank you very much. How to model the changes and how to utilize that and develop further. What is necessary in order to develop further? Yes, we will be looking forward to your further research and discussions. Next is about security, and the next one is industrial security and collaboration in this area. This has started back in 2017, and today on the IIoT value chain security, the role of trustworthiness, we have Ms. Alisa Maftoon from Platform Industry 4.0 AZ3 and Ms. Ayaji Furukawa from Toshiba. Ms. Maftoon, please, the floor is yours.
Hello. Sorry, I was muted before. So today I'm going to talk about the about the white paper that we have written together with Robot Revolution Initiative. The white paper is called Industrial IoT Value Chain Security, the Role of Trustworthiness. So the agenda of this talk is divided into two parts. So I will cover the first three parts, which are mentioned as the goal of our activity, then the white paper and the next steps. And the last two parts would be covered by Furukawa-san. So starting with my presentation, so we have published this white paper that is called Industrial IoT Value Chain Security, the Role of Trustworthiness. It is fourth in line of the collaboration activities that we have done. So Platform Industry 4.0 and Robot Revolution Initiative. And this white paper summarizes or presents an overview of the activities that we have done in the fiscal year 2019. So the overall aim of the white paper is to provide considerations and possibilities for supporting ad hoc trustworthy relationships between companies, regardless of their business histories or their geographical locations. If you want, you can download this white paper on the link provided below. It's published on the website of Platform Industry 4.0. So the use case that we have focused in this white paper is that if considered that there are two companies which are continents apart, for example, one company is in Germany and the other company is in Japan, and they have not previously worked together, so they do not have any business history and they are in different geographical locations, and now they want to do business together. So they require support for creating trustworthy and quick collaboration. So the aim of our activity is to provide support to companies so that they can find trustworthy collaboration partners easily and can establish trustworthy relationships on the go. So keeping this use case in mind, we try to postulate the key issues. And the first key issue is that how to define trustworthiness in the context of supply or value chain security. Then which criteria can be used to determine the trustworthiness of a company and its products? And lastly, what kind of mechanisms are needed for assuring trustworthiness with respect to supply chain or value chain globally? So considering the first key issue, that is how to define trustworthiness, we looked into various definitions of the word trustworthiness. So after our extensive research, we finally decided to adapt the definition that has been proposed by JTC1 Working Group 13, ISO IEC JTC1 Working Group 13, and the definition is as follows. For supply and value chain security and risk management, the term trustworthiness corresponds to the supplier's ability to meet the expectations of the potential contract partner in a verifiable way. And depending on the use case, different characteristics to the word trustworthiness may apply. And these characteristics could be authenticity, integrity, resilience, availability, confidentiality, privacy, safety, accountability, and usability. And having our particular use case that I've discussed earlier in mind, we try to narrow down the criteria of trustworthiness for our work. And we narrowed down to these 4 points. The first is authenticity as a property of an organization's trustworthiness. Then authenticity as a property of product's trustworthiness. Security as a property of an organization's trustworthiness. And lastly, security as a property of product's trustworthiness. Next, we looked into the ingredients for trustworthiness negotiation. So first, we looked into identities. Identities include identities for organizations, such as the National Tax Administration numbers, then identities for employees that are realized in forms of their username, email addresses, credentials, or PKI certificates. Then identities for processes, such as the identities are issued by the operating system to each new process. And lastly, the product identity that is realized in form of barcodes or QR codes. Next, we look into certificates and divided them into two broad categories. The first category is the certificate that are used for authenticating identity, such as the X509 certificates in the public key infrastructure or EIDAS certificates. Then the next category of the certificates are security certification certificates that certify about security of a particular company or a product based on a published standard. So for example, ISO 27000 certificates or IEC 62443 certificates. And lastly, we looked into standards and frameworks. So we looked into national and international standards like ITSI 319412 series, ISO IEC 62443 series, METI CPSF, and NIST CSF. Having looked at these things, we introduced a novel trustworthiness expectations and capabilities exchange protocol in this white paper. So the protocol considers two scenarios. The first scenario, which is shown on the left, the alternate one, is that there's an independent platform and a buyer submits his request for work. And along with his request for work, he also submits his trustworthiness expectations in form of a trustworthiness profile to an independent evaluation platform. Likewise, the supplier prepares his bid, and along with his bid, he also lists down his trustworthiness capabilities in form of the trustworthiness profile and sends it to the platform. Now the platform matches the request of work to the particular bids, and also it matches the expectations to the capabilities, evaluates them, and provides the most appropriate bid to the buyer. The other scenario that we considered is the direct one, which is shown as the alternate 2 on the right side. Here, the buyer directly contacts the supplier. So he prepares his request for work, and likewise, he also lists down his trustworthiness expectations in form of the trustworthiness profile and sends it to the supplier. Similarly, the supplier makes his quote and also fills in his trustworthiness capabilities in form of the trustworthiness profile and sends it to the buyer. Then the buyer can evaluate the expectations, the capabilities corresponding to the expectations based on his own company policy, and then determine that what kind of trust or to what level or to what extent does he want to trust this particular supplier. So the trustworthiness profile that we have talked about in this trustworthiness expectations and capabilities exchange protocol looks like this. So it can be considered as a standardized data structure, which has two broad parts. So one, which is shown on the left, that is the gray part. And the gray part is to be filled by the buyer. And on the right, the yellow-orange part, that is to be filled by the supplier. And in this gray part, there's a top dark gray part in which the buyer will fill in his contact information or identification information. And then in the bottom gray part, that's highlighted as trustworthiness expectations, he would fill his trustworthiness expectations. And these expectations could be in form of standards or regulations, or it could be also the customized questionnaires or customized questions provided by the buyer. So for example, here as an example, I've shown some. So ISO IEC 62443 certificate or ISO 27000 compliance or common criteria or any customized questionnaire can also be attached here. Then the buyer would mention that if he requires some sort of expected validity date, and then if he wants his supplier to be conformant to this particular expectation, and what kind of conformance is required, self-assessment or third-party assessment. Now the buyer would, after filling in his trustworthiness expectations, he would digitally sign this part and send it to the supplier. On the other hand, supplier in a similar way would fill in his contact information in the darker part. Then he, corresponding to each expectation, he would write down that if he's conformant to this particular expectation and what kind of conformance is it, if it's self-assessment or if it's third-party assessment. And then he would attach a proof to that conformance here. Proof could be in form of a scanned paper, or it could be in form of a digitally signed PDF or any machine readable form as well. And if it's a time-dependent proof, then he or she would attach the expiry date of the proof. Likewise, the supplier would digitally sign this part and sends it back to the buyer. Now the buyer would evaluate the profile, match the expectations to the capabilities, and then determine that what kind of trust or to what level of does he want to trust this particular supplier. So the granularity of the trustworthiness expectations is flexible, and it totally depends on the business provider's requirements. So the next steps for us is that we are trying to realize this protocol, trustworthiness expectations and capabilities exchange protocol, in form of a demonstrator, most probably in the next year. And then we're also looking in the aspects of machine-to-machine secure communication. Then we would also, our plan is to look into automated procedures for the development and evaluation of the trustworthiness profile. And lastly, we would look into the options of digitalizing and making the security certification certificates machine readable while maintaining their authenticity and integrity. Thank you. That was all from my side. Feel free to contact me if you have any questions. Now my colleague Ayaji Furukawa would continue with her presentation. Thank you.
Thank you, Alisa. So now I would like to talk about what RRI is doing in this end. As I believe that Alisa explained about the white paper. So based on a white paper, what RRI is doing right now, the security questionnaire for suppliers. This is the checklist that the manufacturer requests from the suppliers. So I would like to introduce this to you. There might be some repetition, but our goal is as follows. In Industry 4.0 and the world of a connected industry, various industries, enterprises, people, machine, and data are connected together, creating new values, products, and services. In such society, new risks are emerging. So what is needed here is to identify security requirements and bring in the trustworthiness. To this end, RRI and Platform Industry 4.0 are discussing and working together. As Alisa from Siemens explained earlier, we put together a white paper this year. Here, RRI decided to put together security questionnaires for suppliers as an action item. The reason why we decided it to be RRI's action item is an increasing risk in connected industries. In a global value network, regardless of borders, confirmation of a holistic trustworthiness, i.e., trustworthiness architecture is required. And manufacturers need to respond to changes in customers' need and develop products satisfying their needs quickly. And also, in order to develop their products, manufacturers need to have close cooperation with suppliers who deliver necessary parts to them. And through internet, manufacturers need to find appropriate suppliers from the world in a timely manner. Also, there is a possibility where a company cannot procure parts from their suppliers due to natural disasters and a pandemic. Should it happen, one needs to find new suppliers which suffice trustworthy security level. And hopefully, this trustworthiness questionnaire, which we are compiling together, would solve these issues and risks. Security questionnaires for suppliers is aiming to be the template for security level baseline, which manufacturers request suppliers. We are hoping responses to these questionnaires enables manufacturers to know suppliers' trustworthiness to see if they actually have a required trustworthiness level in value chain or not. And I believe the level is different from industry to industries and enterprise to enterprise. especially in those manufacturing area where there is no regulations and guidelines which talk about the level to be complied with, such as important infrastructure operators like power companies and defense and automobiles. It is not known what would be the sufficient level manufacturers should request suppliers to comply. In addition, they do not know what would be the key for product securities, which is not covered by ISMS. In those areas, we want our checklist to be a baseline. I know procurement contracts and others will be digitalized further going forward. And I believe our questionnaires can be digitalized as well. In thinking about the questionnaires list, we selected 15 items from 104 outlined in METI's Cyber Physical Security Framework, CPSF. So why did we select from CPSF? CPSF is a security policy that is required for extended supply chain concept, which stems from Society 5.0 and connected industries. CPSF focuses on enterprises and organizations' communications. From cybersecurity perspective, it organizes sources of risk from value creation process into 3 layers and 6 elements. And another important point is that CPSF has comparison table with the words frequently referenced NIST CSF and IEC 62443, International Standard for Control System Security. Questionnaire we are going to create needs to cover the risks in the supply chain extensively. For these reasons, we first refer to CPSF. Now, let me talk about what criteria we used in selecting 15 out of 104 items. There are 4, and the first is the measure core member companies of RRI are already adopting. If you're not doing it, you cannot ask suppliers to do it. Secondly, we selected minimum security measures we wanted suppliers to carry out. Thirdly, we selected from areas of operation, management process, and organization. Technical security requirements, the control device-specific technical requirements are de-scoped this time since they are different for different devices and products. And lastly, we prioritize items like policies, which are at the upstream of security risk management flow. Following pages list up the selected 15 items. I am not going to explain each one of them today, but these are not final version yet. Every month, we are having a conference call with a German counterpart, PI4, to get their feedback on them. So that we can make adjustments or the deletes. From Identify, we selected 5 items: asset management, governance, risk assessment, risk management strategy, and supply chain risk management. And from Protect, 6, identity management and access control, awareness and training, data security, information protection process and procedures, and maintenance. And selected 3 from Detect, anomalies and events, security continuous monitoring, detection process, and picked response planning from respond recovery. How specifically we are going to ask those questions, that's what we are still thinking about. Yet, there are some perspectives that are not available in CPSF, that is, products life cycle. We need to add items for that. And it is illustrated in the left diagram. RRI members discuss over these topics and do this with good advice from Germany. Manufacturers develop and produce products referencing on the needs of market customers and receiving order from them. In this process, they buy necessary parts from suppliers. Similarly, suppliers will develop and manufacture their parts. Also, maintenance is important service, and it is included in this product life cycle. Taking a look at this diagram, we recognize there is a need to add security requirements to development environment, procurement, operation, and maintenance. And they are highlighted in brown. They are 2-1, 2-4, 4-1 in IEC 62443. So what yardstick are we going to employ in selecting the question items? And we are thinking of using 4 criteria. First, 1, already being implemented by members. 2, what we want suppliers to comply. 3, not technical, but related to operation and management. And 4, not specific, but more generic question items. So currently, we are working how to devise question items from these. And not only questionnaires, but we are working on template for responses so that responders can answer the questionnaire easily and the questionnaire can get answers they are expecting. This still is a draft version, but there are 2 key points. The first one is whether there is evidence or not, and what kind of a level that suppliers are sufficing. So, in other words, they can answer with a maturity level. Earlier, Aliza said Platform Industry 4.0 is creating trustworthiness profile. We are thinking of making our questionnaires integrated into their profile so that it can be used globally. And lastly, our mission is to complete this questionnaire by end of this fiscal year. The checklists, if the manufacturers are interested in that, please join us in RRI to discuss with our counterparts in Germany. So please contact us. So with this, I would like to conclude session 3. So Alisa talked about the white paper which we issued, and RRI side, Furukawa explained about what we are discussing over this based on this white paper and what we are thinking of as the future direction. Thank you very much.
Thank you very much, Ms. Maftun and Ms. Furukawa. So the white paper between Japan and Germany has been explained, and how through the value chain trustworthiness could be guaranteed. And as an approach to that, you have the profile as well as the questionnaire framework, and how you have decided on that, and what is it that you need to look into as trustworthiness. I believe that is what you have explained. And I believe now what has been done in Japan as well as Germany will be integrated. I believe the study and consideration will continue, but also I hope that the audience could also take part in these activities. I hope you can keep an eye out on new developments. So once again, thank you very much to the two presenters. Now, we would like to move on to the last topic, which is about collaboration in standardization. Japan-German Standardization Collaboration Chapter 2 is the title. Dr. Jens Gaiko of Standardization Council Industry 4.0 and Professor Fumihiko Kimura, who is a member of Japan-German Standardization Expert Meeting and Professor Emeritus at University of Tokyo, will be speaking. So thank you, and the floor is yours now.
So, konbanwa, and thank you very much, Nakashima-san, for the introduction. So it's a great honor for me to conclude today's presentations or today's symposium together with Kimura-san and to talk about our standardization collaboration. The standardization collaboration is driven by the Platform Industry 4.0, the RRI initiative, and the Standardization Council. So on the next slide, you can see the Vision 2030 as it was launched by the Platform Industry 4.0 last year. Next slide, please. I still see the, thank you. So the Vision 2030 consists of 3 pillars. One pillar is interoperability, one pillar is autonomy or sovereignty, and one pillar is sustainability. And in the previous presentations, we heard already a lot about this. For example, Professor Otto presented on the sovereignty issue and proposed the IDS as an approach for this. Also, sustainability was mentioned as a proposal for future cooperation. And of course, interoperability is a topic which has a lot to do with standardization, and therefore this is one of our topics we are dealing with. Before I go to the our cooperation, I will explain a little bit how we have the sharing of the roles in Germany, and this is shown on the next slide. There you have the Platform Industry 4.0. The platform defines the overall strategy and gives recommendations for this. And the implementation of this strategy is done by the Labs Network Industry 4.0, which is shown on the right side. And they are doing some pilot projects and doing some validation of the concepts. And the results of this are feedback to the standardization work. And on the left side, you can see the Standardization Council Industry 4.0. That's the organization I am representing here today. And we are taking care of the implementation via standardization. On the next slide, you see the roles of the Standardization Council Industry 4.0. There are mainly 4 tasks we have. The one is the collaboration, because this is based on the finding that Industry 4.0 requires cross-connected standards. So we need a cooperation among different organizations and different standard-setting organizations. On the one hand, these are the recognized standardization bodies like ISO and IEC, but also we have a lot of fora and consortia and also some national activities. And we connect all these organizations to work together and to avoid competition among us. Second one is internationalization. This is also very important for us to discuss the concepts we are thinking about in Germany at an early stage with our international partners. For example, Japan was identified as as a key partner very early in this process. And here it is important to really start an open discussion on our concepts, because of course we develop our concepts from a German point of view, but it is very important to take into consideration also the requirements and the ideas and concepts of our partners. The third one is what we call agile standardization. This is the relationship between the Standardization Council Industry 4.0 and the Labs Network Industry 4.0. And here we call it agile standardization because it's a kind of a PDCA-like approach where we do a specification in the standards or in the standards drafts. And then the colleagues from the Labs Network Industry 4.0 have access to these drafts, can implement them in pilot projects, do some validation, and then they feed back their findings to the standardization groups. And by this cycle, we can achieve very good progress for the standardization work. And also we can include the small and medium-sized enterprises to standardization work, because very often small and medium-sized enterprises take part in these pilot projects. And finally, it's our role to orchestrate the standardization work. That means on the one hand, we have a standardization strategy, which is laid down in the roadmap, and then also to implement these recommendations. For the roadmap, you can see on the next slide, there you can see the title of the English standardization roadmap, but I'm very happy that from today there is also a Japanese version is available. Nakashima-san included also the link to the Japanese version in this slide. And so this makes us very happy and very proud that the standardization roadmap, the new edition, is available in Japanese. And also it's available in English and of course in German as well. The aim is to reduce the complexity for this topic and to provide recommendations. So there are more than 100 recommendations in the roadmap. And over 60 experts from industry, academia, and research, they contributed to the roadmap, and this was coordinated by the Standardization Council. We see also this roadmap as a door opener for small and medium-sized enterprises, because it's a very good starting point to get an overview of the very complex standardization world. And the roadmap was presented in July this year. This is the 4th edition. And also you can see down a link to a keynote from the managing director of DKI, Mr. Michael Teigeler, which is available in English. Don't worry, the link is a German page, but the video is in English. So, and it makes me very happy that this is also translated to Japanese. And in February this year, I had a chance to come to Tokyo just before the coronavirus situation became more serious. And at that time, the Japanese version of the 3rd edition was launched. So it's a very good tradition to have this. So now coming to our cooperation, which is shown on the next slide. The cooperation between Germany and Japan on the standardization activities is based on initial contacts from 2016. And earlier today, Mr. Hess from the German Ministry gave a very good overview on the timeline and the history of our cooperation. And in so 2017, the common strategy for the international standardization was launched by the Platform Industry 4.0, the RRI, and the Standardization Council Industry 4.0. And we confirmed the direction to develop the common use cases. Here, for example, we saw the presentation by Professor Ulrich Löwen before, the use of the reference model, identification of standardization requirements, and the support of standardization work. On the next slide, you can see the publications from our standardization cooperation. These have been also shown already by Mr. Hess, and you can see the download link on the presentation of Mr. Hess. So that gives me the chance to go to a more technical point, which is shown on the next slide. So one central concept for interoperability is the so-called asset administration shell, which is shown on the right side. The asset administration shell is a digital twin, the concept of a digital twin in the area of manufacturing. And it's a unique description of an asset containing and linked to all the relevant data. All relevant data means really all relevant data within the life cycle and within the different hierarchies of an Industry 4.0 system. On the left side, you can see the reference architecture model, Industry 4.0. And here you can see, for example, the lifetime and also the hierarchy within a factory. So the asset administration shell can have the data for all these different aspects. How this is done, this is shown on the next slide. So first of all, you can think about an asset administration shell as a container for data, a little bit like the zip file you have here on your PC. So you have a standardized format, and within this container, you have a different so-called submodels. And also the structure of the submodels is a standardized format. The way how it is encoded, this could be a different format, and this could be depending on the technology. For example, during the use of an asset in a so-called shop floor in the factory, you use a different data formats as during the engineering process, or for example, as for modeling a business process. So you can use the different technical formats, but the general principle is the same, and it's based on the standardized principles, and therefore the interoperability is very easy. So what could be the submodels be? As this is shown on the next slide. As I mentioned, these submodels, they contain the different aspects of an asset. And these could be aspects, for example, a digital nameplate, that could be a submodel for energy efficiency, and also it could be a submodel for recycling, for example, containing information how to recycle an asset at the end of life or to establish a circular economy. Let's go into the detail of the digital nameplate. This is shown on the next slide. Such a digital nameplate should contain the same information as today's, I call it analog nameplate, so the one which is on today's products. Or furthermore, the information should be encoded in a machine readable and even more in a machine interpretable format. What does it mean? So we need to use so-called semantic properties like the IAC Common Data Dictionary. Professor Otto mentioned this as a vocabulary. And this is here the same, and I can underline this. So the use of a vocabulary is a very important step for us. Thank you. And so here, Germany proposed to have a closer look in this digital name space, digital nameplate project, and we would like to use this for our cooperation. So going to the next slide. We see again the mapping to different technologies. That's, as I mentioned before, we have the basic principles. They are standardized for the asset administration shell, but for different applications, for different phases in the life cycle, we need the different technologies. And here you can see two examples in this diagram on the right upper side. There is automation ML, which is used for the engineering process, and there is the OPC UA, which is used for the use of a product during the usage period. And these are just two examples to show this. So now this comes to a conclusion of my talk. On the next slide, you can see an overview a little bit what has to be done for the standardization of the asset administration shell. So we need the concept of the asset administration shell. This is already done and published, and already the standardization work started at IAC TC65 in a so-called IAC 63278 series for the asset administration shell for industrial applications. And this work has started, and of course we are very looking forward to cooperate with you. We started some work on the interaction model and the Industry 4.0 language. There we had the chance to have an exchange on this last year during the Hanover Fair. And also we have some work on the information model for the administration shell was published. So you can see there will be further parts of this standard series. But as I mentioned before, this is not ready in Germany. It's not fully finalized. We need the input from your side, and we want to make this to a joint project to establish the intelligent manufacturing for this. And as we saw before, there are many further aspects to done, for example, the security mechanisms, and there we had the presentations before my presentation. So now I come to an end of my presentation, and I'm very open and happy to continue our cooperation. If you have any question, please feel free to contact me or to contact Nakashima-san. And now I'm very much looking forward to see the presentation from Kimura-san. Thank you very much.
じゃあ次、木村です。
Then, Dr. Kimura, please. And please wait while I try to share the presentation. Then, following Dr. Gaiko's presentation, I would like to talk about the second stage plans for Japan-Germany standardization collaboration. Some parts may overlap with what Dr. Gaiko said, but first I'd like to briefly summarize the first stage activities, and then also I'd like to give an outline of the SDP, or the Seamless and Dynamic Engineering of Plants, a report, which is a result of our recent activities, and then talk about the second stage activities outlook. First, a little bit about the first stage activities. And as was mentioned, the RRI and the PI 4.0 webpage carries this report. And here, the use case analysis, which was a major theme of our activities since 2017, is explained here. And I'd like to briefly give an explanation here. As you know, in standardization processes, in order to deepen common understanding, use case is very effective. And there were many methodologies related to use cases, and it has been discussed in multiple levels of abstraction and detail. In Japan and Germany collaboration, using use cases for analysis was very effective in pushing collaboration even further. And the result is this, as we've heard, value-based systems and asset administration, Shell, and SDP, or the Seamless and Dynamic Engineering of Plants, was compiled into a report. And now I'd like to focus on this SDP to explain a little bit. This report itself could be downloaded from our websites. Now, before going into the SDP report, I'd like to talk a little bit about the methodology of use case analysis. In a still developing field like smart manufacturing, in addition to agreeing on the mature technologies, I believe we need to lead standardization based on our future vision. And in such cases, application scenario, which describes such future target, would become important. Now, before going into detailed technical discussion, it is important to discuss and agree on the requirements and the target of standardization. Now, at Platform Industry 4.0, the application scenario is presented and explained using various process life cycles like this. And also the SDP, which I would like to explain, is a production system development process lifecycle management. And there are other various application scenarios that are considered. And if you look at all of these, you will be able to understand the future smart manufacturing. Now, application scenario, and applying that for detailed use cases. Here, we are using Industrial Internet Consortium's Industrial Internet Reference Architecture. I won't go into detail here, but it's from what to do or business viewpoint taken to how to do or the implementation viewpoint. So that is captured systematically in this framework. Now, the ordinary use case that we think about is usage view or functional view. Now, usage view looks at the target system as a black box and looks at the relationship between the system stakeholders. The functional view, in more detail, looks at the information exchange with system and technological processes. And before going into the detailed analysis, at the usage view level, it is important to deeply study the target application scenario to be analyzed, or else you will be losing your focus or overall direction. And as you see here, I would like to just point out one thing, but in SBP, the usage view methodology analysis is done. It's abstract, however, at this usage view level, it is very important that you understand the significance of SDP for the future detailed analysis. But usage view is just a what analysis. In order to take that into a more detailed how analysis, it's not a simple task. And that's where technological knowledge and study would be required. And that's where the technical or technological added value will be created. Now, this is just one example I'd like to share with you. I don't have time to go into detail, but you will be able to read the report if you can download from our web pages. For SDP, all information related to the target system is represented in integrating plant model. In SDP, the changes that occur frequently through the plant engineering, operation, and maintenance will continuously and consistently be created and maintained in integrated plant model in order to realize a competitive engineering business. In order to look at the whole picture, let us look at business view. Here you have a very abstract chart here, but engineering service provider and constructor, those stakeholders, and as well as the customer is also considered. And you can see how they are related to the integrating plant model. And each stakeholder constitute different organizations. And so we can think of multiple different business scenarios. The different colors, the green as well as the orange, shows the different organizations. And the way they belong to these organizations, they may change, and that may create different scenarios. So here we are looking at plant engineering service provider and engineer to order business scenarios. And our purpose is to look at the use case scenario and analyze that in SDP. And so we have to understand this through business view. And based on that, we want to understand usage view. And this is just the first step. In usage view, The target system is put into a black box and is modeled as a system under construction or under consideration. And then the interaction with stakeholders is used to clarify the SDP activities. So without going into detail of how to realize and without too much concern in technical details, you need to consider this scenario. I won't go into detail here. I hope that you can refer to the publications. And in the report, we give 4 different examples. And by reading that, you will be able to understand the significance. For example, installation and replacement of a physical pump. We also give 3 other examples. But so in the first stage of the collaboration, we were able to gain deeper mutual understanding through use case analysis. And then in the second stage, we want to extract more specific standardization issues. So now about what we do in the second stage. We do have a plan. I believe this has been updated or rather uploaded to our RRI and Platform Industry 4.0 web pages. Now, the big objective here in the second stage hasn't changed from the first stage. It's about reaching a common understanding of standardization approaches and concepts, and also open information sharing. And also Industry 4.0, as well as in Germany and connected industries in Japan, we want to harmonize the framework conditions in terms of international standardization. And also, we want to identify standardization requirements toward the future. The scope of our activity. Before going into discussion at ISO-IEC, we want to have some prior study of the subject of standardization. And considering smart manufacturing, we want to have a future vision of that. So discussion and consideration should be done, and we want to have a broader discussion on future standardization issues. So those are the scope of our collaborative activities. And in the second stage, which starts now, what are the topics that we will take up? Of course, this is still under discussion between Japan and Germany, but these are some of the ideas that we have. One is further elaboration on use case, and we will pick more use cases, and we will extract some of the standardization items here. And for smart manufacturing, as Dr. Gaiko said, the asset management is very important. Therefore, some standardization for the asset-related aspects will be picked up. And also for use case, utilization of maturity model will be important. Therefore, the relationship with that and use case will be looked at. And for ISO and IEC, before making proposals, we first want to study what specific standardization issues exist. So these are the things we want to study going forward. So now to summarize and wrap up, Japan and Germany, in relation to international standardization of smart manufacturing, we have had several expert meetings over 3 years, maybe 30 or more meetings in order to share information. And we have had some standardization activities which were compiled into reports. And the meaning and objective of this collaboration activity is to have a place for experts in Japan and Germany to gather so that we can discuss freely anytime we want picking up any theme we want concerning smart manufacturing. From 2017 to 2020, the first stage collaboration took place, and now we do have a Japan-Germany experts open forum. I believe that was one big result of our collaboration, and based on this forum, we can continue our collaboration and discussion. So in the second stage, we want to develop this forum further so that it can develop into a forum for international experts. Some specific issues, ASS, or Dr. Leuven talked about. Edge computing will probably be some of the topics that we will pick up. Of course, we need to discuss what to focus on, but Japan and Germany's industry also should be involved in order to expand our activities further. Thank you very much. That is all from myself.
Dr. Gaiko and Dr. Kibira, thank you very much. So under this topic, there is we have a discuss about the collaboration in the standardization. The platform Industry 4.0, the SCI 4.0, and what kind of collaboration is happening with other organizations, and the recently published the standardization roadmap, and AAS, how important that is to the Germany. Those are the messages that we have heard of from Dr. Gaiko. And in terms of the bilateral cooperation, it is in the second phase and as a new activity framework. Although we have been putting importance to this, but the use case-based approaches will be promoted in the second phase. And as an open discussion forum, we would like to activate more so that we can contribute to the international stage. And that was described by the Dr. Kimura. Thank you very much. So that concludes the respective specific topics. And lastly, we would like to get the feedback from Mr. Hess and Mr. Yano. So starting with Mr. Hess, please.
Dear presenters, dear participants, thank you very much. Thank you very much indeed. This expert forum has brought about some really deep discussions and insights. And as a forum as such, it has brought about the fact that our cooperation between Japan and Germany is not only at best level in terms of the ministries and governments involved, but in particular the companies, the experts within the companies, and this forum has shown this very clearly. And this is to my personal satisfaction as well, because we have the same understanding in terms of security between Germany and Japan, and this is again clearly shown during the conference. And I think that is a very, very good basis for future cooperation. And on a more abstract level, it's the proof that our cooperation is working really good. It's working good on all levels. And this is something we all owe to the simple fact that it's now not the first time we come together, but the 5th year. I would like to use this opportunity and to focus on the activities ahead of us, because there is enough work to be done. At the end of November, we will hold a virtual Gaia X summit. And at the end of January next year, we will have the second conference, Shaping a Globally Secure Industry 4.0 Ecosystem, Enabling International Interoperable Security Policies. It will benefit a lot from our excellent cooperation, as today has shown again. I would like to invite you to that conference that will again be held online. And let's keep our fingers crossed that we all have the chance to meet in person at Hannover Fair next year. But as we all know, that is not for sure right now, but I truly hope that it will happen. Nevertheless, we will have new results in the course of next year that will be presented to all parties involved, and I very much look forward to the next step in our cooperation. Thank you very much. Thank you very much indeed. Goodbye.
And thank you very much. Once again, I'm Yano from METI. As I said at the outset, I believe we were able to hear very exciting presentations, and we heard a lot about data today. Data is the oil of the 21st century, but what's different from oil is that data does not have any physical form. It's not doesn't have any weight, and therefore there are no physical or temporal restrictions. You can transfer it freely, and therefore we have heard about security, data infrastructure today, and usage of big data. What could be done with that? Such discussions, I believe, only happened in the past 10, 15 years, and that infrastructure, how do you make such an infrastructure, will be something that both Germany and Japan should focus on. So 10 years from now, how will these two countries be positioned in the world will depend on our research and also study. And therefore, as the ministry, we will continue to support this collaboration between the two countries so that we can create something that is very stable and sturdy. Therefore, we hope to have your cooperation. Thank you very much for your wonderful input today.
Thank you very much, Mr. Yano. And last but not least, Mr. Nakatomi from RRI is going to give us a closing remark. Thank you very much for your introduction. My name is Nakatomi from RRI. And today, I thank you very much for the precious discussion that we had today. And as we have heard today, RRI is working together with a counterpart in Germany, and we respect each activities and ideas and stimulate each other, and we have been deepening our collaboration every year. Data linkages, a business model, trustworthiness, international standard, the digitalization and IoT area. In order to promote that, there are the very important core issues, and we were able to have a very active opinion exchanges. And owing to the companies from Japan and Germany, as well as the academic area and industries, we believe that their cross-border discussions are supporting this endeavor. And while we are in this COVID-19 pandemic, we are in this uncertainty right now. But as we have heard from the discussion today, yesterday, and day before, the transformation centering around the digitalization will be the key for growth in Corona and post-Corona. Then Japan and Germany are sharing the various issues, but in order to tackle this digitalization and industrial revolution, collaboration between two countries will be very timely from enhancing competitiveness in both countries as well as the international contribution perspective. So RRI will be working harder for the continuous collaboration between two countries. And of course, this is a continuous process, and each area may have a separate schedules. And as Mr. Hess mentioned earlier, And also, as Dr. Otto mentioned, the Gaia X Summit in November and the January 28th and 29th, the conference, those two gentlemen mentioned about those events. Of course, all depends upon how this pandemic will settle down, but we want to see you in Hanover at the time of the Hanover Messe, face-to-face. So in this dark high tide, RRI would like to be the lighthouse which sheds the light for the future path. In order to do so, we would like to collaborate between the Japanese players as well as our counterparts in Germany as well. And once again, can you show us all the presenters today so that we can thank them for their presentation? Nakashima-san, can you show all the presenters' face on the screen? Thank you very much. So today, the audience and the presenters, thank you very much for staying with us for a long period of time. With this, we would like to conclude today's session. And I hope that the collaboration with German partners and RRI, I hope that we can secure assistance in collaboration. Thank you.